Okay, the day one lesson all involved the arc length, which was about circumference, and it was a length, it was a measurement of single dimensional measurement to how far something is. Today we're going to be dealing with sector and segment area, so this is a two-dimensional evaluation, and it's part of the area of the circle. So just like arc length was part of the circumference of the circle, we applied the formula based on that. This sector area is going to represent a portion of the area of the circle. Its formula is created very similarly. It should, if the last one made sense, this should make sense. Just to give you a visual of what a sector looks like, it's just a portion of the circle. So this blue highlighted area here represents the sector. It's defined as a region bounded by two radii in the intercepted arc. So MQ is a radius, QN is a radius, and the arc MN is being intercepted by those. The region created by those pieces is called the sector of the circle. It looks sort of like a piece of pie, maybe, cut a pizza weird, maybe have like this really big piece of pizza here possibly, but that's all a sector of a circle is. And it wants to know the area of the sector MQN. Well, if we go to a full circle formula, a full circle, the area is defined as pi times the radius squared. That's a full circle. Okay, we only have part of a circle. We have a portion of the circle. And just like we did with the length of the arc, we multiplied the whole formula times the portion of the circle we're dealing with. We're going to do the same thing here. So to find the area of a sector, we put A sub sector, just let's A sub sect. It's going to be a fraction times pi r squared. And the fraction is the part of the circle we're dealing with divided by the whole circle. Well, just like the last day, circles have 360, a full circle is 360 degrees. And the central angle is some measure. So I need to know the central angle, I need to know the radius of the circle. As you can see from this picture, I know the central angle is equal to 140, I know the radius is equal to 8. So everything I need to know is within the picture, it's just a matter of applying the formula. And just like the last day we had degrees, radians, if there's any radians to be dealt with here, we need to make sure we focus on that. I'll fill that formula up real quick just in case. So part of the circle, and I'm going to say C in degrees. If I wanted to do a part of a circle when C was in radians, I'll put this over here, part of circle C in radians. Okay. The only difference between the radians and the degrees rule is that C, instead of being divided by 360 degrees, if C is in radians, we have to divide by 2 pi radians. So the formula for the area of the sector would be C over 2 pi times pi r squared. And again, just simplification purposes, this pi is on top, this pi is on bottom. We cancel the pi's that are common. And the area of the sector, if we're in radian form, is going to be C r squared divided by 2. If this does come into play, the radius is being squared, C is not being squared. So be careful with entering your calculator for that. Again, if that happens, we'll deal with that. If it doesn't, I probably won't throw any problems like that at this point. So, looking at this picture, we have the angle in degrees. And again, if this is me doing a homework question, I'm going to write down degrees so that I know that you know that that's important. Since it's degrees, we're using this formula. I need to replace C with 140, R with 8. So I'm going to get the area of the sector equals 140 over 360 times pi times 8 squared. Okay, if this is me typing this in a calculator, it's going to look like this. 140 times 3.14. Now I'm going to type times 64 since I can easily evaluate 8 squared. I could also do times 8 caret 2. The calculator knows how to do either one of those. But if it's easily squared, I usually square it so I don't have to worry about any powers when I'm typing it in. Top, top, top. That's all the top stuff being multiplied, divided by the bottom, 360. So we just enter that correctly, so it's going to look like this. 140 times pi, which is 3.14, times 8 squared, which is 64, divided by 360. We get 78.2. And that's going to be, the unit of length of radius is centimeters. We're dealing with area, so that's going to be centimeters squared. Now just real quick, let me just blow this calculator screen up a little bit so you can see it better. Again, 8 squared equals 64, not terribly difficult to do in our head. Suppose it wasn't, and we had to type it in with this squared thing. So 140 times 3.14 times 8 to the second power divided by 360, and you get the same answer. So again, for me personally, if I can do it easily in my head, I prefer not to type in powers when I'm evaluating. Multiplying and dividing is much more safe, but in a pinch, like let's say the radius is 71.93, type in 71.93 squared. So just keep that in mind, that's an option.